In the deep blue, something the size of 3 school buses is running for its life. Its heart alone weighs as much as a golf cart. Its tail could snap a shark in half with one swing. And yet, right now, it is scared. We call the blue whale the biggest animal to ever exist. Bigger than any dinosaur. Bigger than anything that has ever swum, walked, or crawled on this planet. For decades, we believed nothing on Earth would dare attack it. But in 2019, off the coast of Australia, scientists watched that belief die in real time. Today, we go inside the ocean's most brutal power struggle. A pod of orcas smart enough to hunt the biggest prize in the sea, a mother whale using her own body as a shield, a tail strike strong enough to kill, and a chase across open water where one wrong move ends everything. If this kind of story pulls you in, hit like and subscribe. It helps more than you know. Get ready. The hunt for the ocean's last giant begins now. The water goes quiet. A shadow moves under the surface, longer than a bowling lane stretched 3 times over. Nothing swims toward it. Nothing circles it. In a world full of hunters, this one animal walks through the ocean like it owns every inch of it. The blue whale is the largest animal to ever exist on this planet. Bigger than any dinosaur that ever stomped across dry land. Bigger than anything that has ever breathed air or pulled water through gills. A single blue whale can stretch 100 feet long, the same length as 3 school buses parked end to end. It can weigh up to 200 tons, heavier than 30 elephants standing on one scale. For most of history, people believed this whale had no real enemies. No shark would try it. No creature seemed to have the strength or the nerve. Scientists studied the ocean for decades and rarely saw anything challenge this giant. It seemed like the blue whale had won the game of survival simply by being too big to fail. But size is not the same as safety. A slow-moving giant with a predictable path is not untouchable. It is a puzzle. And in nature, every puzzle eventually finds an animal smart enough to solve it. Picture the blue whale gliding through open water, alone, calm, feeding on tiny shrimp-like creatures called krill. It filters thousands of pounds of these small animals through comb-like plates in its mouth every single day. It has no teeth. It has no claws. It has no armor. Its entire defense system comes down to raw size and a tail that can strike like a sledgehammer. For a long time, that was enough. Sharks stayed away. Smaller predators kept their distance. The blue whale earned a reputation as the untouchable king of the sea, a living monument that nothing could bring down. Then came the years between 2019 and 2021, when a research team off the coast of Australia witnessed something that had never been documented before in the history of science. A group of hunters didn't just approach a blue whale, they attacked it, they chased it, they brought it down. The animal capable of this was not a shark. It was not some deep-sea monster from the pages of legend. It was a hunter already known for intelligence, teamwork, and one of the most feared reputations in the entire ocean, the orca. This discovery didn't just add a new fact to a textbook. It rewrote what scientists thought they understood about power in the sea. If the largest animal in the history of life on Earth could be hunted down, then the ocean's food chain was not as settled as everyone believed. The blue whale still holds an advantage most predators cannot match. Its heart alone weighs as much as a small golf cart. Its tail can generate enough force to seriously injure or kill an attacker with a single well-placed strike. Its body carries endurance that lets it swim for hours without stopping, outlasting almost anything trying to catch it. But endurance and strength only matter if a hunter fights fair, and the ocean's smartest predator does not fight fair. It fights as a team, using strategy passed down through generations, patience measured in hours, and a level of coordination that turns a hunt into something closer to a military operation. That is where this story begins. Not with a monster from the deep, but with a truth stranger than fiction. The biggest animal to ever live still has something to fear. And once you understand exactly what makes this whale so hard to kill, you'll understand exactly why its hunters had to get so terrifyingly smart to do it. Imagine standing next to a school bus. Now imagine 3 of them lined up bumper to bumper. That length, 100 feet, is roughly how long a full-grown blue whale can get. Now try to picture attacking that with your own body, which barely reaches past its flipper. This is the reality every ocean predator faces when a blue whale swims by. The size difference is not close, it is not even in the same category. A great white shark, one of the most feared hunters in the sea, usually grows to around 15 feet long. Line up 6 great white sharks nose to tail, and you still would not match the length of one adult blue whale. Weight makes the gap even more extreme. A blue whale can weigh 200 tons. A great white shark weighs around 1 ton at most. That means a single blue whale can outweigh 200 sharks combined. For any predator sizing up a meal, that math simply does not work in their favour. Nature usually rewards predators that pick fights they can win. A lion does not hunt an elephant alone. A wolf pack does not challenge a fully grown bison without serious risk. Predators size up prey by asking a simple question: can I overpower this safely? For almost every hunter in the ocean, the answer with a blue whale is an immediate no. Even the whale's individual body parts break the normal rules. Its tongue alone can weigh as much as an elephant. Its mouth can hold a volume of water and krill greater than its own body weight in a single gulp. Its heart is roughly the size of a small car, and when it beats, the sound can reportedly be detected from over 2 miles away underwater. Try picturing an animal so large that other massive creatures look small standing next to it. A great white shark next to a blue whale looks like a house cat standing beside a horse. The comparison is not just impressive, it is a survival strategy passed down over millions of years of evolution. This is exactly why sharks almost never attempt to attack a healthy adult blue whale. It is not fear in the way humans experience fear. It is instinct built from millions of years of natural selection. A built-in warning system telling every predator in the sea that this target is not worth the risk. But instinct and math only apply to predators hunting alone. A single great white shark has no realistic path to bringing down a blue whale. A single orca does not either. Even a full orca pod faces enormous risk-taking on prey this large. That is what makes the story of blue whale hunting so remarkable. It required predators willing to ignore the size math completely, banking everything on teamwork, timing, and brutal coordination instead of raw individual strength. Somewhere in the evolutionary history of killer whales, a strategy developed that flipped the entire equation. Instead of asking, "Can I beat this animal alone?" a hunting pod of orcas began asking a completely different question. Can we beat this animal together, using numbers, tactics, and exhaustion instead of size? That single shift in strategy is the reason orcas became the only predator on Earth capable of successfully hunting the largest animal that has ever lived. Every other creature in the ocean looked at the size gap and backed away. Orcas looked at the same gap and saw a plan. Understanding exactly how big this advantage really is sets up everything that follows. Because to understand how something this massive can be brought down, you first have to understand exactly how impossible that should be. Somewhere deep inside that massive body, a single organ beats slow and heavy, sending blood through miles of vessels wide enough for a small child to swim through. This is not an exaggeration. This is the blue whale's heart, and it may be the most powerful engine any living creature has ever carried inside its chest. The blue whale's heart can weigh around 400 pounds, roughly the size of a small golf cart. When it beats, researchers using tags have picked up the sound from over 2 miles away underwater. That single organ pumps enough blood to fill a small swimming pool with every few heartbeats, pushing oxygen through a body longer than a basketball court laid on its side. This kind of power exists for a reason. A body this large needs a delivery system strong enough to keep every part of it running, from the tip of the tail to the massive muscles that drive it forward. Without a heart this powerful, the whale simply could not move its own weight through the water fast enough to survive. Here's where it gets interesting for anyone thinking about attacking this animal. All that raw cardiovascular power connects directly to muscle, and muscle connects directly to speed and force. A blue whale is not some slow, helpless giant drifting through the ocean. It is an athlete built on an unbelievable scale. Under normal conditions, a blue whale cruises at speeds around 5 miles per hour, similar to a person walking briskly. But when threatened, that same animal can burst forward at over 20 miles per hour, roughly the speed of a car driving through a neighbourhood street. For an animal this size, hitting that speed takes an enormous amount of raw power, and that power comes directly from a heart built like an industrial machine. Old whalers used to describe chasing blue whales for 8 to 10 hours straight, only for the whale to swim away easily once the hunters gave up. That kind of endurance does not come from luck. It comes from a cardiovascular system built to outlast almost anything trying to catch it. Think about running a marathon versus sprinting one block. Most animals can do one or the other well, not both. A cheetah is explosive but exhausts quickly. A wolf can run for miles but never reaches top speed. The blue whale somehow balances both, generating bursts of real speed while also being able to sustain effort for hours without stopping. This creates a serious problem for any predator hoping to bring one down. You cannot simply chase a blue whale and wait for it to tire out, because its body was built by evolution specifically to avoid that exact outcome. Its heart does not quit. Its muscles do not fail early. Everything about its internal engine says survive, and survive, and survive again. For a lone predator, that combination of speed and endurance is close to unbeatable. There is no realistic path to wearing this animal down through a straight chase. The math simply does not favour anything hunting alone, no matter how fast or determined that hunter might be. But a heart this powerful also has a weakness hidden inside its strength. An engine this big requires enormous amounts of oxygen to keep running, and oxygen only comes from one place, the surface, through a single opening on top of the whale's head. That single detail, easy to overlook, would eventually become the exact target smart hunters needed. Because if you cannot outrun this animal, and you cannot outmuscle it, there is only one other option left. You have to stop it from breathing. Picture a paddle the size of a small airplane wing, attached to muscles strong enough to launch 200 tons of whale through open water. That paddle is the blue whale's tail fluke, and while it exists to help the animal swim, it doubles as one of the most dangerous weapons in the entire ocean. The fluke spans wide, flat, and packed with muscle fibre built for constant, repeated force. Every downward stroke pushes an enormous column of water backward, driving the whale's massive body forward. That same motion, aimed sideways or brought down hard and fast, becomes something else entirely, a strike capable of seriously injuring or killing anything caught in its path. Think about how a sledgehammer works. The power doesn't come from the swing alone, it comes from weight combined with speed. Now imagine a sledgehammer with the surface area of a small car, moving through water with the force generated by that same golf cart-sized heart. That is what a threatened blue whale can unleash with a single motion of its tail. Researchers who have documented orca attacks on blue whales describe the same defensive pattern again and again. The whale slaps and swipes its tail wildly, trying to strike any predator that gets too close. This is not random panic. It is the whale's only real physical weapon, and it uses it with everything its body has left. Even orcas, which use their own tail slaps to stun smaller prey like seals and rays, understand the danger of getting hit by something this size. A tail strike from a healthy adult blue whale carries enough force to break bones, cause internal injuries, or knock a 20-foot orca completely off balance in an instant. This is why direct contact isn't always necessary. Even swimming close creates dangerous turbulence and pressure changes that can throw a smaller predator off its attack. Here is a comparison that makes it easier to picture. Getting hit by a moving car at low speed can seriously hurt a person. A blue whale's tail moves through dense water, carrying far more mass than any car, all concentrated into a single explosive strike. For an orca weighing a few tons, one solid hit in the wrong spot could end the fight permanently. This single weapon explains a huge part of why so few predators have ever attempted to hunt a blue whale. It is not just about size, it is about the fact that this animal's only defense happens to be genuinely lethal. Unlike prey that simply run or hide, the blue whale can actively fight back with a weapon built into its own body. But every weapon has limits, and the tail fluke is no exception. It can only strike in certain directions. It takes time and space to build up full power, and most importantly, it can only protect one area of the whale's massive body at a time. A single predator attacking alone would likely face the full force of that tail with no way to avoid it. But a coordinated group spread out and attacking from multiple angles at once changes the entire equation. While the tail swings toward one attacker, the whale's head, fins, and blowhole become exposed to the others. This is exactly the weakness that smart, patient hunters would eventually learn to exploit. The blue whale's greatest weapon can only face one direction at a time, and when enough hunters surround it from every side, that powerful tail becomes far less useful than it should be. Most people picture the blue whale as a peaceful giant drifting calmly through open water like a slow-moving cloud. That picture is accurate right up until the moment danger appears. Then everything changes, and this so-called gentle giant becomes something closer to a 200-ton missile. Under normal, relaxed conditions, a blue whale moves at a leisurely pace, somewhere around 5 miles per hour. That's roughly the speed of a person jogging lightly. At this pace, the whale conserves energy while it searches for dense clouds of krill to filter through its massive mouth. But when a threat appears, everything about that calm picture disappears in seconds. A frightened blue whale can accelerate to speeds over 20 miles per hour, comparable to a car cruising through a school zone. For an animal the length of 3 school buses, reaching that speed takes an explosive amount of raw power, and it happens almost instantly once fear kicks in. Here's what makes this truly remarkable. Speed alone is impressive for any large animal, but the blue whale doesn't just get fast, it stays fast. Old-time whalers described chasing blue whales for 8 to 10 hours straight at speeds around 12 miles per hour, only to watch the whale eventually swim away with energy to spare once the hunters gave up from exhaustion. Compare that to a human sprinter. Someone running their absolute fastest might hold that top speed for 10 or 15 seconds before their body gives out completely. Now imagine holding a strong, fast pace for 8 hours without stopping. That is the kind of endurance built into every blue whale's massive muscular system. One researcher who studies these animals compared trying to stop a fleeing blue whale to trying to stop a moving train. The comparison fits perfectly. A train doesn't slow down because you push against it. It keeps moving because its momentum and power overwhelm anything trying to interfere. A blue whale in full flight carries that same unstoppable quality. This combination of speed and endurance creates a serious problem for any predator relying on a simple chase. Sharks, which typically ambush prey with short bursts of speed, have no realistic way to keep pace with a blue whale over any real distance. Even predators built for long-distance swimming struggle to match this level of sustained output. So how do you catch something that can outrun almost anything in the ocean for hours at a time? You don't rely on speed. You rely on numbers, positioning, and patience. A coordinated group of hunters doesn't need to be faster than the whale. It only needs to be smart enough to cut off escape routes, tire the animal through repeated harassment, and force it into open water where there's nowhere left to run. Every burst of speed the whale uses to escape one attacker drains energy it will need later in the fight. This is where intelligence starts to matter more than raw physical ability. Speed protects a blue whale from almost every predator in the ocean, but speed alone cannot protect it from an enemy patient enough to wear it down over time, an enemy smart enough to turn the whale's own advantage into a long, slow disadvantage. That enemy exists, and the moment scientists finally documented it in action, everything we thought we understood about the ocean's food chain needed to be rewritten. For most of modern history, one belief stood unchallenged in the world of ocean science. The blue whale had no natural predators, not sharks, not other whales, nothing. It seemed to exist in its own protected category, too big and too powerful for anything to touch. This belief wasn't just guesswork, it came from decades of careful observation. Scientists tracked blue whale populations across oceans for years and rarely, if ever, witnessed anything resembling a real predatory attack. Occasional scars appeared on some individuals, but confirmed hunting events were nowhere to be found in the scientific record. Think about how strange that actually is. In nearly every environment on Earth, even the biggest, strongest animals have something willing to challenge them. Elephants face lions when young or weak. Bison face wolf packs. Even great white sharks occasionally fall victim to orcas. But the blue whale seemed to break this pattern entirely, floating through the ocean as the one true exception to nature's rules. This gap in the science stayed unsolved because of 2 hard truths working together. First, blue whales spend most of their lives far from shore, in deep open water where researchers rarely get the chance to observe extended interactions. Second, and more importantly, actual predation events on healthy adult blue whales were incredibly rare in general, making them almost impossible to witness firsthand. There was also a darker reason behind this apparent safety. Commercial whaling during the 1900s devastated blue whale populations across the globe, pushing them to the edge of extinction. With so few blue whales left in the ocean, the odds of predators encountering them at all dropped dramatically. Fewer whales in the water meant fewer opportunities for any predator, however capable, to attempt an attack. For decades, this created something close to a scientific blind spot. Researchers couldn't prove predators were hunting blue whales, but they also couldn't prove they weren't. The absence of evidence became mistaken for evidence of complete safety, and the myth of the untouchable blue whale grew stronger with every passing year. Then, international protections and hunting bans slowly allowed blue whale populations to begin recovering. More whales in the ocean meant more opportunities for predators to encounter them, and as populations grew, patient researchers finally started spending enough time in the right locations to witness what had been happening in the shadows all along. Between 2019 and 2021, a research team working off the southwestern coast of Australia witnessed something that shattered the old belief completely. Not once, but 3 separate times, they watched a pod of orcas successfully hunt and kill blue whales, including one healthy full-grown adult. This wasn't a lucky accident caught on camera. These were coordinated, practiced hunts, carried out by predators that clearly understood exactly what they were doing. The events proved that predation on blue whales wasn't some rare fluke of nature. It was a real, repeatable hunting strategy that had likely been happening in secret for far longer than anyone realized. The old myth didn't just get updated, it got completely rewritten. The blue whale, once considered the one truly untouchable animal in the entire ocean, turned out to have a predator capable of ending its life all along. Science simply hadn't been in the right place, at the right time, to see it happen. And once researchers understood this new reality, one question became impossible to ignore. What kind of predator is smart enough, patient enough, and coordinated enough to take down the largest animal that has ever lived? Every predator in the ocean looked at the blue whale and backed away. Every predator except one. The orca, also known as the killer whale, is the single creature on Earth that evolution somehow equipped with the intelligence, teamwork, and raw nerve required to challenge the largest animal that has ever lived. Orcas aren't actually whales at all, despite the name. They belong to the dolphin family, making them the largest members of that group by a wide margin. But calling them just dolphins completely undersells what they're capable of. Orcas sit at the very top of the ocean's food chain, earning their reputation as true apex predators with no natural enemies of their own. What separates orcas from every other hunter in the sea isn't size or strength. A single orca, usually growing to around 20 feet long, is nowhere near large enough to challenge a 200-ton blue whale alone. Instead, what makes orcas dangerous is something far more powerful: intelligence combined with teamwork passed down across generations. Orca pods operate less like random groups of animals and more like coordinated units, following complex hunting strategies that different populations develop and specialize in over time. Some orca families focus entirely on hunting fish. Others specialize in seals, rays, sharks, or even other species of whales. This specialization isn't random, it's learned, taught, and refined across generations, almost like passing down a family recipe. Think about how a football team studies plays before a big game. Each player has a role, a position, and a job to do at exactly the right moment. Orca pods hunt in a strikingly similar way, with different members taking on different responsibilities during an attack, working together toward one shared goal instead of hunting as individuals. This level of coordination comes from something remarkable happening inside an orca's brain. Their brains are large, complex, and built for social learning. Young orcas don't hunt instinctively from birth. They watch, they learn, and they practice hunting techniques taught directly by their mothers and other pod members over years of their lives. This teaching process explains why not every orca pod on Earth hunts blue whales, even in areas where blue whales regularly pass through. Pods that never develop this specific hunting tradition simply don't attempt it, sticking instead to the prey their families have always targeted. Hunting a blue whale isn't instinct. It's a specialized skill taught only within certain orca cultures that developed the knowledge and passed it down. This detail matters because it explains something crucial. Orcas didn't suddenly become capable of hunting blue whales. Certain specific pods, likely over many generations, slowly developed and refined a strategy dangerous enough to take on the largest prey the ocean has ever offered. Off the coast of Western Australia, Near a location called Bremer Canyon, researchers discovered exactly this kind of specialized population, a large, established group of orcas living in an area where migrating blue whales regularly pass close to shore. This wasn't a random encounter waiting to happen. It was a hunting ground where the right predator, the right prey, and the right conditions all came together at once. Understanding orca intelligence changes the entire story. This isn't a tale of brute force overpowering size. It's a story about strategy defeating strength, about patience and teamwork solving a problem that raw power alone could never crack. And to truly understand how dangerous that strategy becomes, you need to see exactly how many orcas it actually takes to bring down one single blue whale. A single orca stands no real chance against a healthy adult blue whale. Even a small group would likely fail, risking serious injury or death for nothing. So when researchers finally documented a successful hunt, the numbers involved revealed something that changed how scientists understood this entire relationship. In the first documented attack off the coast of Australia, in March 2019, roughly a dozen orcas were involved in the initial assault on a 72-foot blue whale. That number alone sounds impressive, but it was only the beginning. As the attack continued and the whale weakened, more orcas arrived from the surrounding area, drawn in by the commotion and the promise of food. By the time the hunt ended, researchers counted approximately 50 orcas involved in various stages of the attack and feeding. In one of the more recent documented events, that number climbed even higher, with over 60 orcas from 5 different family groups joining together around a single blue whale. Think about what that actually means. Picture 60 large dolphins, each one roughly the length of a minivan, surrounding a single animal at once. That's not a hunt in the traditional sense. It's closer to a coordinated siege, an overwhelming show of numbers designed to remove every possible advantage the whale's size would normally provide. This large group size solves a problem that would otherwise make the hunt impossible. A blue whale's tail can strike with enough force to seriously injure or kill an attacker, but that tail can only face one direction at a time. With a dozen or more orcas attacking from every angle simultaneously, the whale physically cannot defend every side of its body at once. There's another reason large numbers matter so much here. A blue whale's greatest advantage besides size is stamina. The ability to swim at high speed for hours without stopping. A small group of orcas would tire long before the whale did, giving up the chase in exhaustion just like the old whaling ships once did. But a large group can rotate, taking turns pressing the attack while others rest, keeping constant pressure on the whale without ever letting up. This creates an overwhelming mismatch that raw strength alone could never achieve. The whale isn't fighting one opponent that eventually tires and retreats. It's fighting a rotating wall of attackers that never fully backs off, wearing the animal down minute after minute until its enormous reserves of strength and endurance finally run out. The arrival of additional orcas partway through an attack also reveals something fascinating about how these hunts unfold in real time. Sound travels efficiently through water, and orcas communicate constantly using clicks and calls. When one pod locates a blue whale and begins an attack, that information appears to spread quickly to nearby orca groups, drawing in reinforcements almost like a call for backup. By the final documented case, researchers described the scene as something closer to an alliance than a single hunting party. 5 separate orca families combining forces around one target. This wasn't coincidence. It suggested a level of coordination extending beyond just one pod, into a broader network of orcas capable of recognizing an opportunity and responding together. Understanding this scale changes the entire picture of what's happening beneath the surface during one of these hunts. This isn't one clever predator outsmarting a slower, weaker animal. It's an entire coordinated army, using every advantage numbers can provide, working together to bring down the single largest and most powerful creature the ocean has ever produced. And once that army surrounds its target, the next question becomes obvious. How exactly does an attack this size actually unfold, moment by moment, once the fighting begins? March 2019 started as an ordinary day of research for scientists working off the southwestern coast of Australia. Teams from the Cetacean Research Centre and Project Orca were conducting annual surveys, tracking whale and dolphin populations along the coastline. Nobody expected to witness history that day. The weather turned rough, with heavy skies and choppy water making conditions difficult for observation. One researcher later described it as a really ominous bad weather day, the kind of afternoon that usually cuts a survey short rather than delivers a breakthrough discovery. Then, cutting through the grey water, the crew spotted something unusual. A group of orcas, moving with clear purpose and coordination, surrounding something enormous. As the research vessel moved closer, the scene coming into view seemed almost impossible to believe. An adult blue whale, 72 feet long, was under active attack. This moment mattered because nothing like it had ever been scientifically documented before. Researchers had spent decades studying blue whales without ever witnessing a confirmed predatory attack on a healthy adult. What unfolded next would completely rewrite that history. The orcas worked with obvious coordination, targeting specific areas of the whale's massive body. Bite marks appeared across its fins and flippers as the attack intensified. The whale's head showed signs of a severe wound, with damage extensive enough to expose bone beneath the surface. This wasn't a random, chaotic assault. It was calculated, precise, and clearly practiced. Throughout the attack, the blue whale fought back using its only real weapon, slapping and swiping its enormous tail in every direction, trying desperately to strike any orca that came within range. Researchers watching from the boat described the whale's attempts to flee, using bursts of speed to try to escape the growing circle of predators closing in around it. But escape wasn't an option. Every direction the whale turned, more orcas were waiting. The attack continued for approximately 20 minutes before the exhausted, badly wounded whale could no longer keep fighting. Within roughly an hour of first being spotted, the pod had successfully brought down the largest animal on the planet. What happened next revealed just how significant this event truly was. Word seemed to spread beneath the surface, and more orcas began arriving at the scene, likely drawn in by underwater sounds and signals from the original hunting pod. By the time the feeding frenzy reached its peak, researchers estimated the total number of orcas involved at around 50, with roughly 30 still actively feeding on the carcass when the research crew eventually left the area. For the scientists on board, the emotional weight of the moment was enormous. They were witnessing something that experts in the field had never previously confirmed, an actual documented case of orcas successfully hunting and killing a fully grown healthy adult blue whale. One researcher involved in later analysis called it simply the biggest predation event on the planet, a phrase that captured both the scale and the historic significance of what had just occurred. This single encounter didn't happen in isolation. It marked the beginning of a pattern that researchers would go on to document 2 more times over the following 2 years, each event adding crucial pieces to a puzzle that marine science had been missing for generations. The ocean had just revealed one of its best-kept secrets, and this was only the first chapter of a much bigger story still unfolding beneath the waves. 20 minutes. That's roughly how long it takes to eat lunch, watch part of a movie, or scroll through a phone without noticing time passing. For a pod of orcas hunting a blue whale, that same short window of time is all it takes to bring down the largest animal that has ever lived on Earth. Understanding exactly what happens during those 20 minutes reveals just how calculated and brutal this process really is. This isn't random chaos. It's a structured, practiced sequence of moves, each one building on the last, slowly stripping away every advantage the blue whale would otherwise have. The attack typically begins with positioning. Orcas spread out around the whale, cutting off potential escape routes before the whale even realizes what's happening. Blue whales rely heavily on open water and straight-line speed to escape danger, so the first priority for attacking orcas is limiting that open space, forcing the whale into a smaller, more controlled area. Once positioned, the orcas begin targeting specific parts of the whale's body. Fins and flippers become an early focus, not because they're deadly targets, but because damaging them slows the whale down and reduces its ability to maneuver effectively. Imagine trying to run at full speed with someone pulling on your arms and legs at the same time. Even a small amount of resistance dramatically reduces your speed and control. The tail comes next, one of the most dangerous parts of the attack for the orcas themselves. This is the whale's primary weapon, and getting close enough to grab or damage it means accepting real risk. But slowing the tail reduces the whale's ability to generate the powerful strikes it desperately needs for defense, while also cutting into its remaining speed and stamina. As the whale weakens and its movements become less coordinated, the attack shifts toward its head. This stage becomes especially brutal, with orcas targeting the area around the blowhole directly. Some orcas push down on the whale's head from above, while others position themselves beneath the whale's body, pushing upward to prevent it from diving to escape. This coordinated pressure from both directions traps the whale at the surface, unable to escape downward and unable to fully surface for a clean breath. Every time the whale attempts to breathe, orcas interfere, making each breath shorter and more difficult than the last. Think about how quickly panic sets in when you can't catch your breath, even for just a few seconds. Now imagine that struggle stretched across 20 continuous minutes, against opponents who never stop pressing the attack. The whale's massive lungs, built to hold enormous amounts of oxygen for long, deep dives, become useless when it can't get a full breath in the first place. Throughout this entire process, the whale continues fighting back with everything it has left. Tail strikes continue, sometimes catching an orca off guard, sometimes missing entirely as exhaustion sets in. But every ounce of remaining energy goes toward defense and escape, energy that continues draining with each passing minute. By the 20-minute mark, the outcome has usually already been decided. The whale's movements slow, its attempts to flee become weaker and less coordinated. The combination of blood loss, oxygen deprivation, and complete physical exhaustion overwhelms even a body built on the largest scale nature has ever produced. This sequence, precise, coordinated, and devastatingly effective, explains exactly why researchers describe these hunts as practiced rather than lucky. The orcas involved clearly understood exactly what they were doing at every single stage. But understanding how orcas stop the whale from moving only tells part of the story. The true key to this entire strategy lies in that single, vulnerable opening on top of the whale's head, the one weakness that turns an unbeatable giant into a target. Every living creature that breathes air shares one unavoidable weakness. No matter how strong, how fast, or how massive an animal becomes, it eventually has to come up for air. For the blue whale, the largest animal on Earth, that single requirement turns out to be the exact crack in its armour that made everything else possible. Blue whales breathe through a blowhole located on top of their heads, a single opening that connects directly to their lungs. Unlike fish, which pull oxygen from water through gills, whales are mammals, meaning they must return to the surface regularly to take in air, just like humans do. This creates an unavoidable pattern. No matter how powerful a blue whale's tail strikes, no matter how fast it can swim, it cannot survive without eventually surfacing to breathe. And smart, patient predators figured out exactly how to turn that basic biological need into a devastating weakness. During a coordinated attack, orcas use a specific and calculated strategy targeting this exact vulnerability. Some orcas position themselves above the whale's head, pushing downward with their combined weight and strength to prevent the blowhole from ever fully breaking the surface. At the same time, other orcas swim beneath the whale's body, pushing upward to block it from diving deep enough to escape the pressure from above. Picture someone trying to hold a beach ball underwater from both directions at once, pressing down from the top while blocking any path downward at the same time. The ball has nowhere to go. It stays trapped in that same narrow space, unable to move freely in either direction. That's essentially what happens to a blue whale's head during this stage of the attack. This double-sided pressure prevents the whale from taking a full, clean breath. Every attempt becomes shorter, more rushed, and less effective than the last. Over time, this leads to something scientists call asphyxiation, a slow, forced suffocation caused by preventing normal breathing rather than through any single fatal strike. This strategy explains why these attacks can succeed even against an animal capable of generating incredible speed and devastating tail strikes. Speed doesn't matter if you can't breathe. Strength doesn't matter if your body starts running out of oxygen. The orcas essentially bypass the whale's greatest physical advantages entirely, attacking a weakness that speed and power simply cannot defend against. This tactic isn't unique to blue whale hunts either. Researchers have observed similar blowhole blocking strategies used by orcas hunting other large whale species, suggesting this technique represents a well-established and highly effective method passed down through generations of hunting knowledge within certain orca populations. Study co-author Robert Pittman, a cetacean ecologist involved in analysing these documented attacks, described the orcas involved as experienced, practiced hunters who clearly understood exactly what they were doing throughout each stage of the hunt. This wasn't guesswork or luck, it was a calculated strategy, refined and repeated with devastating precision. The brutal effectiveness of this approach also explains why these hunts, while incredibly demanding, can succeed in such a short window of time. Instead of trying to physically overpower an animal built to withstand overwhelming force, the orcas simply remove its ability to breathe, turning the ocean's greatest survivor into a creature fighting an enemy far more basic and far more inescapable than any predator's teeth. Every advantage the blue whale carries, its size, its speed, its powerful tail, exists to help it survive predators, avoid danger, and outlast pursuit. But none of those advantages matter if the most basic requirement for staying alive, a single breath of air, gets taken away. And once you understand this single vulnerability, it becomes clear why certain blue whales face far greater danger than others, especially the smallest, weakest members of the species still learning to survive in an ocean full of hidden threats. If hunting an adult blue whale feels nearly impossible, hunting a calf tells a completely different story. Smaller, weaker, and far less experienced, blue whale calves represent a far more realistic target for predators looking for a real chance at success, and this single difference completely changes the entire dynamic of the hunt. A newborn blue whale calf already enters the world at an enormous size, often comparable to the length of a school bus, but compared to a full-grown adult stretching 100 feet long and weighing 200 tons, that same calf looks small and vulnerable by comparison. This size gap creates a much more realistic opportunity for predators to actually succeed. Size isn't the only disadvantage calves face. Adult blue whales develop their incredible speed and endurance over years of growth and physical development. A calf simply hasn't built that same level of strength yet. Its muscles are still developing, its stamina hasn't reached full adult capacity. Running from danger at high speed for hours simply isn't something a young calf's body can manage yet. Experience matters just as much as physical development. Adult blue whales have spent years learning to sense danger, recognize threatening situations, and react quickly to avoid trouble. A calf, still learning basic survival skills from its mother, lacks that same instinctive awareness. It may not recognize approaching danger quickly enough to react in time. This combination of smaller size, limited strength, and inexperience makes calves the most realistic and frequent target for orca predation. In fact, of the 3 documented blue whale hunts off the coast of Australia between 2019 and 2021, one directly targeted a blue whale calf, while another involved a large juvenile roughly 40 feet long, only about half the length of the fully grown adult killed in the first attack. But hunting a calf still presents one enormous obstacle standing directly in the way: its mother. Blue whale mothers form an incredibly close bond with their calves, staying near them constantly during the vulnerable early months of life. This creates a serious complication for any predator hoping for an easy meal. A blue whale mother, despite the added danger of protecting her calf, still carries the same massive size and devastating tail strike capable of seriously injuring or killing an attacking predator. This means orcas hunting a calf cannot simply ignore the mother swimming right beside it. They have to account for a second, fully capable defender fighting alongside the primary target. This is exactly why calf hunts often require just as much coordination and numbers as adult hunts, sometimes even more. Orcas must find ways to separate the calf from its mother, or overwhelm both animals simultaneously, all while avoiding the mother's powerful defensive strikes throughout the entire process. This dynamic reveals something important about the relationship between blue whales and their predators. It's not simply about picking the easiest possible target, it's about weighing risk against reward, choosing when a smaller, weaker prey animal makes an attack worth attempting, even when that same prey remains protected by one of the most powerful defenders in the entire ocean. Understanding this trade-off sets up one of the most fascinating parts of this entire story: the incredible lengths a blue whale mother will go to protect her calf, using her own body as a living shield against predators capable of killing the largest animal that has ever lived. There is no armor in the ocean stronger than a blue whale mother standing between her calf and danger. No weapon more determined, no defense more absolute. When predators threaten a young blue whale, its mother becomes something closer to a moving fortress, using every ounce of her massive body to protect her offspring. Blue whale mothers invest an enormous amount of energy raising their calves. Newborns already enter the world at an incredible size, but they still require months of nursing, guidance, and protection before they're ready to survive fully on their own. This deep investment explains why mothers respond to threats with such intense, unwavering defensive behaviour. When danger approaches, a blue whale mother often positions her own massive body between the threat and her calf, physically blocking access using pure size and mass. Picture a defensive lineman stepping directly in front of a smaller teammate, using their much larger frame to absorb contact and protect the person behind them. That's essentially the strategy a mother blue whale relies on instinctively. This positioning does more than simply block access. It forces attacking predators to deal with the mother's full-size threat before ever reaching the smaller, more vulnerable calf behind her. And as previously shown, dealing with a full-grown adult blue whale, even one focused on defense rather than escape, remains an incredibly dangerous task for any predator. The mother's tail becomes an especially critical weapon during these encounters. Powerful downward and sideways strikes create not just direct impact, but dangerous turbulence and pressure changes in the surrounding water. An attacking predator positioned even a few feet away can be knocked off balance or disoriented by these underwater shockwaves without ever being directly struck at all. This turbulence effect matters more than it might initially seem. Coordinated attacks depend heavily on precise positioning and timing between multiple predators working together. A single well-placed tail strike, even one that misses its intended target, can disrupt that coordination, throwing off the timing an entire hunting group depends on to succeed. Calves gain additional benefits simply by staying close to their mothers during dangerous encounters. Swimming directly behind or alongside a mother allows a calf to take advantage of something called drafting, using the reduced water resistance created by the mother's much larger body to conserve precious energy during high-speed escape attempts. This matters enormously during extended chases. While calves lack the raw stamina of a full-grown adult, drafting behind their mother allows them to maintain higher speeds for longer periods than they could manage entirely on their own, buying crucial extra time during a dangerous pursuit. Despite these incredible defensive efforts, researchers have documented cases where predators successfully attacked and killed blue whale calves, even with a defending mother present. These events remain rare and require intense coordinated effort from a large predator group, but they demonstrate that even the fiercest maternal defense cannot guarantee complete protection against a large enough and determined enough hunting force. Still, these successful defensive efforts happen far more often than failed ones. The combination of overwhelming size, dangerous tail strikes, and the protective drafting effect gives blue whale calves a fighting chance they would never have completely alone, all thanks to a mother willing to risk everything for her offspring's survival. This maternal bond reveals something deeper about these massive animals beyond simple survival instinct. It shows a level of dedication and sacrifice that feels remarkably similar to protective behaviours seen throughout the animal kingdom, reminding us that even the largest creature to ever exist still fights fiercely for the ones it loves. But not every encounter between blue whales and predators ends in an active, visible battle. Sometimes the evidence of these dangerous encounters shows up much later, written permanently across the surface of a whale's skin. Long after an attack ends, the ocean keeps a record. Written across the skin of countless blue whales are pale, rake-like scars, permanent reminders of encounters with predators that never made it into any research report or documentary footage. These marks tell a story science almost missed entirely. For decades, confirmed predatory attacks on blue whales remained incredibly rare in the scientific record. But researchers studying blue whale populations noticed something that didn't quite match this apparent safety. Many individual whales carried distinctive scarring patterns across their bodies, marks that looked remarkably similar to teeth rakes left behind by orca attacks. Photo identification studies, where researchers photograph and catalogue individual whales based on unique markings, revealed something significant. In the Gulf of California, approximately 1 in every 4 blue whales studied showed these telltale rake-like scars, physical evidence suggesting a close encounter with orcas at some point during that individual's life. Think about what that percentage actually means. If you gathered 100 blue whales together in one place, roughly 25 of them would carry visible proof of surviving a serious predator encounter. That's not a rare exception. That's a genuinely common experience shared across a significant portion of the entire population. This discovery created an important shift in how scientists understood the relationship between blue whales and orcas. Confirmed kills remained extremely rare in the observed record, but failed or interrupted attacks appeared to happen far more frequently than anyone had previously realized. The whales survived these encounters, but they carried permanent physical evidence of just how close they came to a very different outcome. This raises an important question. If confirmed successful kills were so rarely observed, why did so many whales carry scars from attacks? The most likely explanation points directly back to the whale's impressive defensive capabilities discussed earlier. Powerful tail strikes, incredible speed, and sheer size allow many blue whales to successfully fight off or outrun attacking orcas even when the attack has already begun. In other words, these scars represent successful defenses far more often than failed ones. Every rake mark tells a story of a blue whale that fought back hard enough, swam fast enough, or simply proved too dangerous and too exhausting a target, ultimately forcing attacking orcas to abandon the hunt before it could be completed. This pattern also helps explain why researchers went so long without documenting an actual successful kill. Attacks were clearly happening with some regularity throughout blue whale populations worldwide. But most of these encounters ended with the whale escaping, wounded but alive, leaving behind scars rather than a confirmed predation event for scientists to witness and record. The rarity of confirmed kills combined with the frequency of visible scarring suggests something important about the true nature of this predator-prey relationship. It's not simply about whether orcas can successfully hunt blue whales. It's about how often they try, and how often those attempts end in a hard-fought escape rather than a successful hunt. This scarring evidence adds crucial context to everything documented in the confirmed 2019 through 2021 attacks. Those events weren't isolated, unprecedented anomalies happening for the very first time. They were simply the rare instances where a long-standing, ongoing pattern of predation finally became visible enough for researchers to witness and record in complete detail. The scars prove one final important point. Blue whales exist in a world far more dangerous than their reputation as an untouchable giant would suggest. And while their defenses succeed far more often than they fail, every single scar serves as permanent proof that danger remains a constant, lurking presence throughout their entire lives. While orcas represent the ocean's most capable blue whale predator, they're far from the only large hunter that shares these same waters, and the relationship between blue whales and one of the ocean's other most feared predators, the shark, tells a completely different story altogether. Sharks have earned a fearsome reputation across the entire ocean, feared by seals, fish, and even humans in certain situations. But when it comes to blue whales, even the most feared sharks in the sea choose the exact same strategy every single time: complete avoidance. Unlike orcas, which have developed specific hunting strategies capable of successfully targeting blue whales, sharks show no evidence of ever attempting a coordinated attack on a healthy adult or even a juvenile blue whale. This isn't a matter of sharks lacking aggression. It comes down to basic biology and simple survival math working directly against them. Consider the great white shark, widely recognized as one of the ocean's most dangerous predators. Even this feared hunter typically grows to around 15 feet long, a fraction of the length of a full-grown blue whale stretching up to 100 feet. This massive size difference alone makes any potential attack extremely risky and largely impractical. A shark's hunting strategy relies heavily on specific physical advantages that simply don't translate well against an animal built on this scale. Sharks typically attack through ambush, using surprise and a single powerful damaging bite to injure or kill their prey before it can react effectively. This strategy works well against seals, fish, and other prey closer to the shark's own size. But a blue whale presents physical challenges that make this strategy nearly impossible to execute successfully. A shark's jaw, while incredibly powerful, isn't built wide enough to deliver a meaningful bite against a body as massive as a blue whale's. Even the largest bite a great white shark could manage would represent only a tiny fraction of the whale's overall body mass, causing minimal damage against such an enormous target. There's also the danger posed directly by the whale's own defensive capabilities. That same powerful tail strike capable of seriously injuring an attacking orca poses an equally serious threat to any shark unfortunate enough to get within striking range. A single well-placed hit could easily kill or seriously injure a shark attempting an attack, making the entire attempt an extremely poor trade of risk versus potential reward. Sharks also lack the coordinated group hunting strategies that make successful orca attacks possible in the first place. While some shark species do occasionally hunt cooperatively, they don't display anything close to the complex, multi-stage coordination orcas use when targeting large whales. Without that teamwork, sharks simply don't have a realistic path toward overcoming a blue whale's size and defensive capabilities. Given all these factors working against them, sharks generally choose the smartest possible strategy, staying away entirely. Sharks have access to countless other food sources throughout the ocean, prey far closer to their own size that presents dramatically less risk and far greater odds of success. Attempting to challenge a blue whale simply doesn't make sense when easier, safer options exist everywhere else. This doesn't mean sharks and blue whales never interact at all. Sharks will readily scavenge from blue whale carcasses when the opportunity arises, feeding on remains left behind after the whale has died from other causes, including the aftermath of successful orca attacks. But scavenging an already deceased whale carries none of the risk involved in actively hunting a living one. This clear pattern of avoidance highlights just how uniquely dangerous and specialized true blue whale predation actually is. It's not simply about being a large, aggressive predator somewhere in the ocean. It requires a very specific combination of coordinated teamwork, learned strategy, and sheer numbers, qualities that set orcas apart as the only realistic predator capable of successfully challenging the largest animal that has ever lived. But there's one common point of confusion that often gets mixed into this conversation: a completely different animal that shares part of the blue whale's name but almost none of its actual biology or behaviour. Take a closer look at exactly why a shark's bite fails so completely against a blue whale, and the answer comes down to pure physical mismatch. Understanding this mismatch reveals just how much size alone can serve as a genuine, functional form of defence in the natural world. A great white shark's jaw, while undeniably powerful, is built specifically for prey within a certain size range. Seals, sea lions, and smaller marine mammals typically measure anywhere from a few feet up to around 10 feet long. A shark's jaw evolved to open wide enough and generate enough bite force to seriously injure or kill prey within that specific size category. Now compare that to a blue whale's body. Even a newborn calf enters the world already stretching around 23 feet long, more than double the length of many typical shark prey items. A fully grown adult reaches lengths nearly 7 times longer than the shark itself. This creates an enormous gap between what a shark's jaw was built to handle and what it would actually be attempting to bite. Think about trying to take a meaningful bite out of a city bus using only your own mouth. No matter how hard you tried or how sharp your teeth happen to be, the sheer size difference makes any real damage essentially impossible. That's roughly the same challenge a shark faces when even considering an attack on a blue whale. Beyond simple size, blue whales carry an incredibly thick layer of blubber beneath their skin, sometimes measuring several inches deep across most of their body. This thick padding serves multiple purposes, including insulation against cold ocean temperatures, but it also acts as a natural buffer against potential bite damage, absorbing and spreading out impact across a wider area rather than allowing deep, concentrated injury. Even if a shark managed to land a solid, direct bite somewhere on a blue whale's body, the resulting wound would likely represent only a tiny, insignificant injury relative to the whale's overall size and total blood volume. A blue whale's body holds an enormous supply of blood, all pumped by that 400-pound heart mentioned earlier. A single shark bite simply couldn't cause enough blood loss or physical damage to seriously threaten an animal operating on this massive biological scale. This is precisely why documented cases of sharks actually attacking healthy blue whales remain essentially non-existent in scientific literature. It's not a matter of sharks choosing not to attack out of some sense of caution or fear in the way humans typically understand fear. It comes down to a basic biological reality. Sharks physically lack the tools necessary to inflict meaningful damage against prey built on this incredible scale. This stands in sharp contrast to how orcas successfully overcome the exact same size challenge. Rather than relying on a single powerful bite, orcas use coordinated group tactics, targeting specific vulnerable areas like fins, tails, and the blowhole, while overwhelming the whale's ability to defend every angle simultaneously. Sharks simply don't possess this same level of complex social coordination or strategic hunting behaviour. This comparison highlights an important lesson about survival in the natural world. Raw physical power alone doesn't guarantee predatory success. Strategy, coordination, and specialised technique often matter far more than simple bite force or individual strength when facing prey built on an overwhelming physical scale. Understanding this distinction sets up one final point of confusion that frequently comes up in conversations about blue whales and sharks, a mix-up between two completely different animals that happen to share a surprisingly similar name. Say the words whale shark to someone unfamiliar with ocean life, and confusion often follows almost immediately. Is this some kind of hybrid creature? A shark that hunts whales? A whale disguised as a shark? The truth turns out to be far simpler and far less dramatic than the name alone might suggest. A whale shark is not related to whales at all. Despite the name, it's actually the largest species of shark in the entire ocean, not a whale, and not any kind of predator targeting whales whatsoever. The name comes purely from its massive size, which happens to rival many actual whale species, rather than from any biological relationship or shared ancestry. Whale sharks can grow to impressive lengths, with some individuals reaching up to 60 feet long. That's an enormous size for any shark species, easily making it the largest fish currently living in the ocean today. This impressive size is exactly where the naming confusion originally began, comparing this massive shark scale to that of actual whale species. But size represents pretty much the only meaningful similarity between whale sharks and true whales, like the blue whale. Despite their intimidating size, whale sharks are remarkably gentle animals, feeding almost exclusively on plankton, krill, and small fish, filtered through their enormous mouths in a process quite similar to how baleen whales like blue whales actually feed. This peaceful feeding behaviour makes whale sharks about as far from a dangerous predator as you can possibly get, despite their massive, imposing size. They pose no meaningful threat to blue whales, to humans, or to virtually any other large animal in the ocean. In fact, divers regularly swim alongside whale sharks in the wild without facing any real danger at all. This creates an interesting irony directly tied to the confusion around their name. A whale shark, despite carrying whale directly in its title, shares far less in common with an actual blue whale than you might initially expect, at least in terms of danger and predatory behaviour. Meanwhile, the actual danger to blue whales comes from an animal carrying an entirely different name altogether, the orca, commonly and somewhat confusingly known as the killer whale. This naming pattern adds even more confusion to the mix. Orcas aren't technically whales at all. Despite carrying whale directly in their common name, as mentioned earlier, they actually belong to the dolphin family, making them the largest species within that specific classification. So to summarise this tangled web of naming confusion, the whale shark isn't a whale and poses no real threat to blue whales at all. Meanwhile, the killer whale isn't technically a whale either, but represents the single most significant predatory threat blue whales actually face throughout their entire lives. Common names, it turns out, don't always accurately reflect what an animal truly is. This confusion serves as a helpful reminder of just how important scientific classification and complete understanding become when studying ocean predators. Surface-level names and simple assumptions based on labels alone can easily mislead people, especially when the true complete story turns out to be far more complicated and genuinely fascinating than a name could ever fully capture on its own. With this important point of confusion now cleared up completely, the story can move forward, deeper into the specific location where blue whales and their most dangerous predator regularly cross paths, a stretch of Australian coastline that has become nothing short of an underwater battleground. Off the southwestern coast of Australia, hidden beneath the surface, lies a massive underwater trench called Bremer Canyon. To the naked eye, the ocean here looks calm, blue, and unremarkable. But beneath that surface sits one of the most dangerous predatory hotspots ever documented anywhere on the planet. Bremer Canyon plunges to incredible depths, creating a steep underwater drop-off along the continental shelf. This kind of geography matters enormously in the ocean world. Deep canyons like this one push cold, nutrient-rich water up from the depths toward the surface, a process scientists call upwelling. That nutrient-rich water fuels massive blooms of plankton and krill, which in turn attract larger and larger animals up the food chain. Think of it like a highway rest stop that happens to be built directly on top of an enormous, endless buffet. Animals travelling through the area have every reason to stop, feed and linger, rather than simply passing through on their way somewhere else. This exact combination of geography and food supply turned Bremer Canyon into one of the richest feeding grounds anywhere in the southern hemisphere. Blue whales, following ancient migration routes between feeding and breeding grounds, regularly travel directly along this same continental shelf drop-off. Their migration patterns bring them close to shore in this specific region, funneling them straight through an area already known for another remarkable population living nearby. That population happens to be one of the largest concentrations of orcas found anywhere in the southern hemisphere, with researchers estimating over 150 individual orcas calling this general region home. This isn't a small, occasional group passing through. It's an established, thriving population that has clearly adapted to take full advantage of everything this rich environment has to offer. Put these two facts together, and the picture becomes impossible to ignore. A major blue whale migration route runs directly through territory containing one of the largest orca populations on Earth. This isn't coincidence. It's exactly the kind of overlap that creates repeated opportunities for encounters between predator and prey. This explains why all three of the groundbreaking documented blue whale hunts between 2019 and 2021 happened in this exact same general area. It wasn't random luck that researchers happened to witness multiple attacks in roughly the same region within just a few years of each other. It reflects a consistent, ongoing pattern created by the specific geography and ecology of this one remarkable stretch of coastline. Researchers studying the area have come to view Bremer Canyon as something close to a natural laboratory for observing large-scale predator behaviour. The consistent presence of both blue whales and hunting orcas in the same location, combined with regular access from research and whale-watching vessels, has created unprecedented opportunities to observe and document behaviours that might otherwise remain completely hidden from human eyes. This location has since become closely associated with dramatic orca hunting behaviour beyond just blue whales. The same population has been documented successfully hunting other massive prey, including great white sharks, further cementing this region's reputation among scientists as one of the most active and important predatory hotspots anywhere in the world's oceans. Understanding Bremer Canyon helps answer an important question raised earlier in this story. These attacks weren't isolated, unprecedented anomalies happening for the first time in history. They were the visible result of a long-standing specific set of conditions, geography, food supply and population density that had likely been creating opportunities for this kind of predation for a very long time, before researchers ever managed to witness it directly. Understanding this unique location naturally raises another important question. If encounters like this have likely been happening for generations in this specific area, how exactly did the knowledge and skill required to successfully hunt a blue whale get passed down and refined within these specific orca populations over time? Somewhere within the pods of Bremer Canyon, a young orca watches closely as its mother approaches a massive moving target. It doesn't know exactly what to do yet. But over the coming years, through repeated observation and practice, it will slowly learn one of the most dangerous and complex hunting strategies in the entire animal kingdom. Orcas don't hunt blue whales through pure instinct. Unlike many predatory behaviours seen throughout nature, which animals seem to know automatically from birth, hunting techniques this complex and specialised require active teaching and learning across an orca's early life. This process closely resembles something surprisingly familiar, passing down family traditions and skills from one generation to the next. Scientists refer to this process as cultural transmission, essentially the passing of learned knowledge and behaviour from one generation to another within a specific social group. While cultural transmission exists throughout the animal kingdom in various forms, few species display it as clearly and consistently as orcas do when it comes to specialised hunting behaviour. Young orcas spend years alongside their mothers and other close pod members, observing every stage of successful hunts long before they ever actively participate themselves. This extended learning period allows calves to absorb an enormous amount of specific knowledge, including exactly which prey to target, how to coordinate with other pod members, and which techniques prove most effective against specific types of prey. Think about how a skilled chef might teach a specific family recipe to their child, patiently walking through each individual step across many years, rather than simply expecting the recipe to be understood immediately. That same patient, repeated teaching process happens within orca pods, except the lessons being taught involve something far more dangerous than cooking. This teaching process explains a fascinating pattern researchers have observed across different orca populations worldwide. Different groups of orcas, even those living in relatively similar ocean environments, often specialize heavily in completely different types of prey. Some populations focus almost exclusively on fish. Others specialize in hunting seals, rays, sharks, or larger whale species. This specialization isn't determined by genetics or physical differences between populations. It's determined almost entirely by learned tradition, passed down carefully across many generations within each specific family group. An orca born into a population that specializes in hunting large whales will likely learn and eventually practice that same specific skill throughout its own life. This cultural transmission process also explains why certain specific orca populations, like the one found near Bremer Canyon, developed the extremely rare and specialized ability to successfully hunt blue whales, while countless other orca populations around the entire world have never been observed attempting anything close to this same behavior. The skills required for a successful blue whale hunt are remarkably complex, involving precise coordination, careful timing, and specific knowledge about exactly where and how to attack such an enormous, dangerous target. This isn't a simple behavior that could realistically develop independently and instinctively within every single orca population across the globe. Instead, it likely represents specialized knowledge that developed within one specific population, or perhaps a small handful of populations, then continued being carefully taught and refined across many successive generations. Each new generation of young orcas learns directly from parents and other experienced pod members, continuing this incredibly specific and dangerous tradition forward through time. This reveals something remarkable about orca intelligence that goes far beyond simple problem-solving ability. It demonstrates a genuine capacity for culture itself, the ability to develop, refine, and pass down complex learned behavior across multiple generations, something scientists once believed was largely unique to humans alone. Understanding this cultural learning process raises an equally interesting question from the opposite direction. If specific orca populations develop and pass down these specialized hunting skills, what happens with the countless other orca pods around the world that never develop this same dangerous tradition at all? Not every orca on Earth poses a threat to blue whales, even when the two species happen to cross paths in the exact same waters. Across different regions of the world's oceans, countless orca populations exist that have never attempted, and likely never will attempt, hunting a blue whale, despite clearly having the same basic physical capabilities as the specialized hunters found near Bremer Canyon. This might initially seem confusing. If orcas throughout the world share the same basic body structure, similar intelligence levels, and comparable social hunting abilities, why would only certain specific populations develop the skill and willingness to hunt such an enormous, dangerous target while others never attempt anything close to it? The answer connects directly back to the cultural learning process discussed in the previous chapter. Because hunting techniques this complex require active teaching and generational knowledge transfer rather than pure instinct, orca populations that never developed or learned this specific skill simply have no internal knowledge or established strategy for successfully executing this kind of hunt. Think about how a family with no hunting tradition might never teach their children specific outdoor survival skills, even if physically capable of learning them, simply because that particular knowledge was never part of their specific family history or teachings. The physical capability exists, but the learned knowledge required to actually put it into practice does not. This same principle applies directly to orca populations worldwide. Different groups of orcas essentially become locked into their own established hunting traditions, passed down carefully across many generations. A population that has spent generations specializing exclusively in hunting seals, for example, has no accumulated cultural knowledge about how to successfully coordinate an attack against something as massive and dangerous as a blue whale. Researchers studying orca behaviour have noted that these populations tend to remain remarkably conservative, sticking closely to established, proven hunting traditions rather than experimenting with completely new and highly risky prey choices. This conservative behaviour actually makes complete sense from a survival standpoint. Attempting an entirely new, unfamiliar hunting strategy against dangerous, unfamiliar prey carries enormous risk, particularly against an animal capable of seriously injuring or killing careless attackers. Without generations of accumulated knowledge about exactly how to safely and effectively execute a blue whale hunt, an inexperienced orca population attempting this same behaviour for the first time would face a significantly higher risk of serious injury or death, all without the benefit of proven, refined techniques passed down through careful teaching. This explains why confirmed blue whale predation events remain incredibly rare worldwide, despite blue whales and orcas sharing overlapping territory across many different ocean regions globally. The physical opportunity for interaction exists in numerous locations, but the specific cultural knowledge and learned skill required for a successful hunt exists only within a very small number of highly specialized orca populations. This pattern reveals something important about the true nature of the danger blue whales actually face throughout their lives. It's not a universal threat present everywhere blue whales happen to travel. It's a highly localized, specific danger, concentrated primarily within certain regions where specialized orca populations have developed and maintained this particular dangerous tradition across many generations. For blue whales traveling through most of the world's oceans, encountering an orcapod poses relatively little direct predatory risk, since most populations lack the accumulated knowledge and established strategy necessary for a successful attack. But for blue whales traveling directly through specific regions like Bremer Canyon, where specialized experienced hunting pods have developed this rare and dangerous skill, the level of genuine risk increases dramatically. Understanding this crucial distinction between different orca populations sets up an important question about what actually happens beneath the surface before a hunt like this even begins. Because before any physical attack takes place, there's an entire invisible world of underwater communication and detection happening first, one that plays a critical role in how these predators locate and coordinate against their massive targets in the first place. Long before a single orca makes physical contact with a blue whale, an entire invisible battle has already been unfolding beneath the surface, fought not with teeth or tails, but with sound. In the vast, often murky depths of the open ocean, sound travels farther and faster than sight ever could, making it the primary tool both predator and prey rely on to understand their surroundings. Water conducts sound remarkably efficiently, travelling roughly 4 times faster underwater than it does through air. This means sounds produced deep in the ocean can travel incredible distances, sometimes stretching for many miles, long before that same sound would ever become detectable through normal underwater vision, which becomes extremely limited even in relatively clear water. Orcas rely heavily on this acoustic advantage, using a variety of clicks, calls and whistles to communicate with other pod members across significant distances. This constant underwater communication allows coordinated hunting groups to share information, maintain group cohesion, and coordinate complex movements, even when individual orcas might be spread out across a wide area of open water. This communication system becomes especially important when a hunting pod first locates a potential blue whale target. Once contact is established, information about the discovery appears to spread quickly through underwater vocalizations, potentially reaching other nearby orca groups within the surrounding area. This would help explain why additional orcas frequently arrive at documented attack sites well after the initial hunt has already begun. Blue whales aren't silent participants in this underwater sound world either. In fact, blue whales produce some of the loudest sounds generated by any animal on the entire planet. Low-frequency calls capable of travelling extraordinary distances through open ocean water. These powerful vocalizations primarily serve communication purposes between whales, particularly during mating season and while navigating vast migration routes. However, these same loud, distinctive vocalizations may create an unintended vulnerability. Powerful sounds travelling across long distances could potentially help alert nearby orca populations to a blue whale's exact location and movement patterns, essentially broadcasting its presence across a wide area without any way to prevent or control that same signal from reaching potential predators. This creates an interesting evolutionary tension. Blue whales rely heavily on these powerful vocalizations for essential communication and navigation purposes, benefits clearly important enough to have persisted throughout their evolutionary history. But that same reliance on loud, long-distance sound may simultaneously increase detection risk in regions containing established specialized predator populations. Beyond simply locating a potential target, sound plays an equally critical role throughout coordinated attacks. Researchers believe orcas likely use constant vocal communication throughout a hunt to help coordinate complex multi-stage attacks involving numerous individual hunters working together simultaneously from different positions and angles. This underwater communication network helps explain the remarkable coordination researchers have observed during documented attacks. Orcas approaching from multiple directions, applying pressure at the blowhole while simultaneously targeting fins and tail, requires extremely precise timing and positioning between numerous individual predators. Achieving this level of coordination becomes far more realistic when constant real-time communication exists between every member of the hunting group. This invisible underwater sound war ultimately reveals another crucial layer hidden beneath the visible drama of these dramatic hunts. What appears to observers as a sudden, chaotic attack actually represents the final, visible stage of a much longer process, one built on detection, communication, and careful coordination happening entirely out of human sight and hearing. Understanding this acoustic world naturally leads toward an even more specialized biological tool orcas rely on throughout this entire process, an ability that goes far beyond simple communication into something closer to a built-in targeting and navigation system. Beyond simple communication, orcas carry something even more remarkable built directly into their biology, a natural sonar system called echolocation. This ability transforms sound from a simple messaging tool into something closer to a built-in scanning device, allowing orcas to see their surroundings using sound waves instead of light. Echolocation works through a fairly straightforward process, even though the biology behind it is remarkably advanced. Orcas produce rapid clicking sounds that travel outward through the water. When those sound waves strike an object, whether it's a fish, a rock, or a massive blue whale, they bounce back toward the orca as an echo. By analysing the timing, direction, and pattern of these returning echoes, an orca's brain builds a detailed mental picture of everything around it. Think about how a bat navigates through complete darkness using a similar system, producing sound and interpreting the echoes to avoid obstacles and locate insects. Orcas apply this same basic principle underwater, except with far greater sophistication, allowing them to detect not just the general location of an object, but detailed information about its size, shape, density, and even movement patterns. This ability becomes especially valuable in the open ocean, where visibility often becomes extremely limited due to depth, murky water, or simple distance. While human vision underwater might extend only a limited distance even in clear conditions, echolocation allows orcas to detect and analyze objects across much greater ranges, regardless of available light or water clarity. When it comes to hunting a blue whale, this sonar-like ability provides several critical advantages throughout every stage of an attack. Before an attack even begins, echolocation likely helps orcas detect a blue whale's presence long before visual contact would ever become possible, especially in deeper water or during low visibility conditions common throughout much of the open ocean. Once contact is made, echolocation continues providing valuable information throughout the entire hunting process. Orcas can use returning echoes to build an increasingly detailed picture of the whale's exact body structure, potentially helping identify specific vulnerable areas like the tail, fins, or blowhole region discussed in earlier chapters, even in situations where visual observation alone might prove difficult or unreliable. This detailed sensory information becomes especially valuable during the chaotic, fast-moving conditions of an actual attack. With multiple orcas approaching from different angles simultaneously, all while a wounded, panicked blue whale continues thrashing and attempting to strike back with its powerful tail, maintaining accurate spatial awareness becomes absolutely critical for avoiding serious injury while still executing an effective, coordinated attack. Echolocation likely also plays an important role in helping individual orcas track their pod members' relative positions throughout an attack, an essential component for maintaining the kind of precise coordination discussed in previous chapters. Knowing exactly where nearby orcas are positioned helps prevent dangerous collisions or interference between hunting individuals, while also helping ensure attacks from multiple directions remain properly timed and coordinated. This remarkable sensory tool essentially gives orcas a significant advantage that blue whales simply don't possess in the same way. While blue whales rely primarily on their powerful low-frequency vocalizations, mainly for long-distance communication, orcas combine communication with active, real-time environmental scanning, creating a far more complete and adaptable sensory picture of their immediate surroundings. Combined with the complex social coordination and learned hunting strategies discussed throughout this story, echolocation represents one final crucial piece of the puzzle, explaining exactly how orcas successfully overcome the enormous size and strength advantages held by blue whales. It's not simply about brute force or numbers alone. It's about superior sensory information, allowing for smarter, safer, and more precisely coordinated attacks against an incredibly dangerous and powerful target. With every piece of the hunting strategy now fully understood, from communication and coordination to precise sensory targeting, the story naturally shifts toward the aftermath of a successful hunt, revealing exactly what happens once the chase finally ends and feeding begins. Picture looking down from above at the exact moment a successful hunt finally ends. The water, once relatively calm, now churns violently across a wide area. Blood spreads outward in dark clouds. Dozens of dark fins break the surface again and again, moving in constant overlapping patterns across the entire scene. This chaotic, dramatic picture represents what researchers actually witnessed and documented during the feeding stage following a successful blue whale hunt. Once the whale's defenses finally give out completely, the scene shifts almost immediately from active predatory attack into an intense, large-scale feeding event, unlike almost anything else found anywhere in the natural world. As mentioned earlier, the total number of orcas involved in these feeding events often grows dramatically beyond the original hunting group. What might begin as an attack involving a dozen or so orcas can quickly expand to 50 or even 60 individuals once feeding begins, as additional orcas from the surrounding area arrive after detecting the commotion through underwater sound. This creates an absolutely massive feeding event, one single blue whale carcass providing enough food to sustain an enormous number of individual predators simultaneously. Given that an adult blue whale can weigh up to 200 tons, there's an incredible amount of available food, more than enough to feed dozens of hungry orcas without any real competition or conflict over the remaining resources. Researchers observing these events describe orcas tearing away large chunks of flesh and blubber, then dispersing into smaller feeding groups scattered around different sections of the massive carcass. Rather than a single, chaotic free-for-all, this pattern suggests at least some level of organisation even during the feeding stage, with different groups claiming and working through different portions of the whale's enormous body. The scale of this feeding event becomes even more remarkable when considering just how quickly it unfolds. In some documented cases, researchers noted that nearly 30 orcas remained actively feeding on the carcass even as the observing research vessel eventually left the scene, suggesting the entire feeding process likely continued for a significant period beyond what scientists were able to personally witness and document. This large-scale feeding behaviour reveals something important about the broader ecological impact of a single successful blue whale hunt. Unlike smaller prey, which might feed only a handful of orcas before being completely consumed, a single blue whale represents enough biomass to significantly benefit an entire regional orca population all at once. Beyond directly feeding the orcas themselves, these massive feeding events likely benefit numerous other species throughout the surrounding ecosystem as well. Scraps and remains drifting away from the main carcass provide opportunities for scavenging sharks, various fish species and seabirds circling overhead, all taking advantage of the sudden, enormous influx of available food spreading throughout the surrounding water. This ripple effect throughout the local ecosystem highlights an important ecological point often overlooked when focusing purely on the dramatic predator-prey relationship between orcas and blue whales. A single successful hunt doesn't just benefit the immediate hunting pod, it creates a temporary but significant boost of available nutrients and food resources, benefiting an entire web of species living throughout the surrounding marine environment. Understanding the true scale of this feeding event helps explain exactly why researchers and scientific experts have described these documented hunts using such dramatic, significant language throughout their published research and public statements. This isn't simply a single predator successfully catching a single prey animal. It represents an enormous ecosystem-level event with far-reaching effects extending well beyond the immediate hunting group itself. This remarkable scale naturally raises an important question about exactly how researchers and scientists have chosen to describe and categorize this specific type of predatory event within the broader context of animal behavior and predation observed throughout the natural world. 60 minutes. That's roughly the total time it took from the very first sighting to the final moments of active feeding for one of the most significant predatory events ever documented in the natural world to fully unfold. Within that single hour, an entire temporary underwater ecosystem sprang to life around the remains of one enormous blue whale. Breaking down this hour reveals just how much happens within such a relatively short window of time. The initial attack itself, as detailed earlier, typically lasted around 20 minutes before the whale's defences were fully overcome. But that represents only the beginning stage of a much longer, more complex event still unfolding beneath the surface. Once the whale's life ended, the feeding stage began almost immediately, with orcas quickly transitioning from active predatory behaviour into intense, coordinated feeding. This transition happened remarkably fast, suggesting the hunting pod understood exactly what came next, moving efficiently from the dangerous work of the hunt into securing their well-earned reward. As previously explained, the total number of orcas involved often expanded significantly during this feeding stage, sometimes growing from an initial hunting group of a dozen individuals up toward 50 or 60 total orcas by the time feeding reached its peak. This rapid expansion happened within the same general time frame as the entire event, meaning additional orcas arrived, located the carcass, and joined the feeding process all within roughly the same single hour. Think about the sheer amount of coordination and communication required to make this happen so quickly. Orcas arriving from potentially miles away needed to detect the commotion, likely through the underwater sound communication discussed earlier, then navigate directly toward the exact location, arriving in time to participate in active feeding, all within a remarkably tight window of time. This entire process, from first sighting to widespread feeding, represents what researchers have described as nothing short of the single largest predation event ever documented on the planet. That description isn't simply dramatic language chosen for effect. It reflects a genuine, measurable reality based on the sheer scale of biomass involved, combined with the number of individual predators participating simultaneously. Consider comparing this single event to almost any other documented predatory interaction found throughout the natural world. Most predator-prey encounters, even those involving large, powerful predators, typically involve much smaller amounts of biomass and far fewer participating predators working together at any given time. A single blue whale hunt, by comparison, involves the largest possible prey animal combined with an unusually large number of coordinated predators. Study co-author Robert Pittman captured this significance clearly when describing these documented hunts, suggesting nothing comparable had likely been witnessed since the era of dinosaurs, and possibly not even then. This striking comparison highlights just how genuinely rare and significant this type of predatory event truly is, even when considering the entire history of life on Earth. This bloody dramatic hour also carries important scientific weight beyond simply representing an impressive, dramatic natural spectacle. It provides researchers with an incredibly rare, detailed window into predator-prey dynamics operating at the absolute largest possible scale found anywhere in the natural world, offering valuable insights that could never realistically be gathered through laboratory study or smaller-scale observation. Understanding the true significance of this single hour helps explain why researchers dedicated so much careful analysis and published research specifically toward documenting and understanding these particular events in complete detail. This wasn't simply an interesting nature encounter worth a passing mention. It represented a genuinely unprecedented scientific opportunity, one that fundamentally changed our understanding of predation at the very largest possible scale. With the full scope and significance of these hunts now clearly established, the story naturally shifts toward exploring exactly why scientists consider this specific type of event so uniquely important within the broader context of everything previously understood about predation throughout the natural world. When researchers finally published their detailed findings about these documented blue whale hunts, they didn't hold back on describing the true significance of what they had witnessed. Study co-author Robert Pittman, a respected cetacean ecologist, described the event using language that immediately caught attention throughout the entire scientific community and beyond. Calling this the biggest predation event on the planet wasn't simply an attempt to generate dramatic headlines or media attention. This description reflects a carefully considered scientific assessment based on measurable factors that genuinely set these specific hunting events apart from virtually every other predatory interaction ever documented throughout the natural world. Consider exactly what factors go into measuring the true scale of any predation event. Total biomass involved represents one crucial factor, essentially how much total living material gets transferred from prey to predator during a single successful hunt. Given that adult blue whales can weigh up to 200 tons, no other predator-prey interaction anywhere on Earth comes close to matching this same scale of biomass transfer. Compare this to other well-known large predation events throughout the natural world. Lions hunting large prey like buffalo or giraffes involve biomass measured in hundreds, sometimes low thousands of pounds. Even other documented cases of orcas hunting large whale species such as grey whales or humpback whales typically involve prey substantially smaller than a full-grown adult blue whale. Beyond simple biomass, the number of individual predators actively participating adds another important dimension to measuring true scale. As detailed in previously, these specific hunting events often involved between 50 and 60 individual orcas participating across the combined hunting and feeding stages. This represents an unusually large coordinated predatory group, even by orca standards. Robert Pittman's comparison to the age of dinosaurs adds crucial historical and evolutionary context to this significance. Blue whales represent the largest animals to have ever existed throughout the entire history of life on Earth, larger than any dinosaur species that ever walked across ancient landscapes. This means a successful predation event targeting a blue whale automatically represents predation against the single largest possible living target that has ever existed in the complete history of our planet. This historical framing helps explain why researchers view these specific documented events as genuinely unprecedented rather than simply another interesting example of large-scale predation. Nothing comparable exists anywhere else in the fossil record or throughout modern scientific observation, given that no animal larger than a blue whale has ever existed at any point throughout Earth's entire natural history. This significance extends beyond simply representing an impressive, dramatic, natural spectacle worth scientific attention. These documented events fundamentally reshaped scientific understanding regarding predator-prey relationships operating at the absolute largest possible scale, providing crucial new information that simply didn't exist within the scientific record beforehand. Prior to these specific documented events, scientists could really only theorize about how such extreme, large-scale predation might actually unfold in practice, relying primarily on educated speculation rather than direct, confirmed observation. These events transformed that previous theoretical speculation into confirmed, detailed scientific fact, based on direct observation from multiple credible research teams across 3 separate documented hunting events. This transformation from theory into confirmed observation represents exactly why the scientific community responded with such genuine excitement and significant attention toward these specific published findings. Rather than simply adding another minor data point toward existing knowledge, these events fundamentally expanded our understanding of what's truly possible within the natural world's ongoing predator-prey relationships. Understanding why scientists consider this the single biggest predation event in recorded history naturally raises an important question about timing. Why did these groundbreaking observations only occur recently? rather than being documented decades or even centuries earlier throughout the long history of ocean research and exploration. To understand why these remarkable predation events only became visible to scientists in recent years, we have to look backward through history toward one of humanity's most destructive chapters involving the world's oceans, commercial whaling. This dark historical period directly connects to why these attacks weren't documented sooner. Throughout the early and mid-1900s, commercial whaling operations targeted blue whales extensively across nearly every ocean on Earth. Advanced hunting technology combined with massive commercial demand for whale oil and other products led to devastating population losses, pushing blue whales to the very edge of complete extinction within just a few short decades. Before commercial whaling began, scientists estimate blue whale populations may have numbered in the hundreds of thousands worldwide. By the time international protections finally began taking effect during the mid-20th century, populations had crashed catastrophically, leaving only a small fraction of the original global population still alive throughout the entire world's oceans. This dramatic population collapse created a direct, measurable effect on predator-prey dynamics between blue whales and orcas. With so few blue whales remaining scattered across such vast ocean territory, the statistical odds of orcas encountering blue whales at all dropped significantly, regardless of whether specific orca populations possessed the hunting skill and knowledge necessary for a successful attack. Think about trying to find one specific type of car driving somewhere within an entire country, versus trying to find that same car type driving within just one small city. When blue whale populations were severely depleted, opportunities for any kind of predator encounter, successful or otherwise, became statistically rare purely due to reduced population density spread across such enormous ocean territory. Following international bans on commercial whaling that took effect starting in the 1960s and continuing through subsequent decades, blue whale populations slowly began recovering across various regions worldwide. This recovery process happened gradually, extending across many decades, given the species' naturally slow reproductive rate and lengthy time required for individual whales to reach full maturity. As blue whale populations slowly increased throughout recent decades, opportunities for encounters between blue whales and orca populations naturally increased as well. More blue whales swimming through regions containing specialized orca hunting populations directly translates into increased opportunities for predatory interactions to occur, simply based on basic population statistics and encounter probability. This population recovery likely represents a significant contributing factor, explaining why researchers only recently began documenting confirmed successful blue whale hunts, despite decades of previous dedicated ocean research and observation throughout various global regions. The specialized hunting knowledge itself may have existed within certain orca populations for a considerable period, but actual opportunities to successfully execute that specialized knowledge required blue whale populations to first recover to a sufficient level. This creates a genuinely fascinating, if somewhat ironic, ecological connection. Conservation efforts specifically designed to protect and help recover blue whale populations following historical human overexploitation may have simultaneously created increased opportunities for a completely different, entirely natural predator to successfully hunt that same recovering population. This doesn't suggest conservation efforts were somehow misguided or unsuccessful. Blue whale population recovery represents a genuine conservation achievement worth celebrating, but it does highlight an important complex reality regarding how ecosystems naturally readjust and rebalance themselves following major disruptions, sometimes creating new dynamics and relationships that hadn't been clearly visible or measurable during periods of severely reduced population levels. Understanding this crucial historical connection between whaling history and current predation patterns raises an important question about the future. As blue whale populations potentially continue recovering further over upcoming decades, what might that mean for the frequency and scale of future documented predatory encounters between these two remarkable ocean species? Blue whale populations continue their slow, gradual recovery decades after commercial whaling nearly drove the species toward complete extinction. This recovery represents genuine conservation progress worth celebrating, but it also creates an important question worth carefully considering. What happens as this recovering population increasingly encounters a predator smart enough, patient enough, and skilled enough to successfully hunt it? Current population estimates suggest blue whale numbers remain significantly below historical levels that existed before commercial whaling began. While exact global population figures remain difficult to calculate precisely, given the species' vast migration ranges and generally solitary behaviour patterns, most researchers agree the overall population continues trending in a positive, gradually increasing direction across most studied regions worldwide. This continued population growth means more individual blue whales travelling through migration routes, overlapping with established orca hunting territories, similar to the specific situation found near Bremer Canyon discussed earlier. More blue whales travelling through these specific regions naturally translates into increased statistical opportunities for encounters with orca populations already possessing the specialised hunting knowledge required for successful predation. This creates an interesting dynamic worth considering carefully. Unlike most recovering endangered species, which typically face reduced predation pressure specifically because their historical predators may have also declined or shifted behaviour patterns during the same time period, blue whales appear to be recovering directly into contact with a predator population that has seemingly maintained, and potentially even refined, its specialised hunting capabilities throughout this same extended time frame. Orca populations near documented hunting hotspots like Bremer Canyon haven't faced anywhere near the same historical population pressures that blue whales experienced throughout the 20th century. This means the specialised hunting knowledge and cultural traditions discussed earlier likely continued being taught and refined across successive orca generations, even during periods when blue whale populations remained severely depleted and encounters were comparatively rare. Think about what this means moving forward. As blue whale populations potentially continue their recovery over upcoming decades, they're not simply returning to some previous, safer historical baseline. They're returning to an ocean environment containing predator populations that have maintained specialised hunting traditions in a completely different position compared to prey experiencing genuinely reduced predation pressure during their own population recovery process. This doesn't necessarily suggest blue whale conservation efforts face serious new threats capable of derailing overall recovery trends. As detailed throughout earlier chapters, successful predation events remain genuinely rare, requiring incredibly specific combinations of location, timing, and specialised orca populations. The vast majority of blue whales throughout their entire lives will likely never encounter this specific predatory threat at all. However, this dynamic does highlight an important consideration for researchers and conservation specialists monitoring blue whale population recovery moving forward. Understanding predation patterns, even relatively rare ones, becomes an increasingly important factor when tracking overall population health and growth trends across recovering endangered species populations. Researchers continuing to study regions like Bremer Canyon will likely play an important role in monitoring exactly how this predator-prey relationship continues evolving, as blue whale populations potentially continue recovering over upcoming years and decades. Continued documentation and careful long-term observation will help provide increasingly accurate data regarding exactly how significant this specific predation pressure ultimately becomes for overall blue whale population trends. This ongoing relationship between recovery and predation adds an important layer of complexity to conservation efforts. Successfully protecting and helping recover an endangered species doesn't simply mean guaranteeing complete safety from every possible natural threat. It means allowing that species to return to its natural ecological role, complete with all the same complex predator-prey relationships that existed long before human interference dramatically altered natural population levels in the first place. With this broader population dynamic now clearly understood, the story shifts toward examining a specific, smaller variant of blue whale that faces its own unique set of challenges within this same complex predatory relationship. Not every blue whale swimming through the ocean reaches the same massive proportions typically associated with the species. A smaller subspecies known as the pygmy blue whale exists alongside its larger relatives, and this size difference creates an important, distinct dynamic worth exploring within the broader predator-prey relationship discussed throughout this story. Pygmy blue whales represent a genuinely distinct subspecies, generally smaller than the blue whales found throughout other global regions like Antarctica. While the largest blue whale populations can reach lengths approaching 110 feet, Pygmy blue whales typically max out around 90 feet, a noticeable size difference even though both remain absolutely massive by any normal standard of comparison. This might not initially sound like a particularly significant difference, but remember everything discussed throughout earlier chapters regarding exactly how much size alone functions as genuine, effective defense against potential predators. Even a relatively modest size reduction compared to larger blue whale populations could meaningfully impact overall vulnerability when facing a determined, coordinated predator group. Pygmy blue whales are found specifically throughout regions including waters near Australia and other areas throughout the Indian and Pacific Oceans, placing significant portions of this specific subspecies population directly within migration ranges overlapping with established, specialized orca hunting territories like Bremer Canyon. This geographic overlap becomes particularly significant when considering the documented hunting events detailed earlier. Some of the specific whales targeted during these confirmed attacks were described as smaller individuals, potentially representing either young juveniles or possibly members of this specific smaller pygmy subspecies, rather than the larger blue whale populations found throughout other regions like Antarctica. Think about how this creates a particularly challenging combination of risk factors. Pygmy blue whales already carry a somewhat reduced size compared to their larger relatives, while simultaneously spending significant portions of their migration routes travelling directly through regions containing some of the most specialised, experienced blue whale hunting orca populations found anywhere throughout the entire world's oceans. This overlapping combination of factors suggests pygmy blue whales specifically may face somewhat elevated predation risk compared to larger blue whale populations found throughout other global regions with less established orca hunting traditions. However, researchers continue studying this specific relationship carefully, since definitively separating risk factors specifically tied to size versus simple geographic overlap remains scientifically complex. This situation highlights an important broader point regarding how predation risk doesn't distribute evenly across an entire species. Even within blue whales as a single overall species, meaningful variation exists regarding exactly how much individual risk different populations and subspecies actually face, based on a complex combination of size, geographic range, and direct overlap with specialized predator populations. Conservation efforts focused specifically on protecting pygmy blue whale populations may need to carefully account for this specific predation dynamic, alongside other more commonly discussed threats like ship strikes, fishing net entanglement, and ocean pollution that typically receive greater conservation attention and dedicated research funding. Understanding this specific subspecies dynamic adds important nuance to the broader predator-prey relationship discussed throughout this entire story. It's not simply a uniform, evenly distributed risk applying equally across every blue whale on the planet. It's a complex, geographically concentrated risk, disproportionately affecting specific populations and subspecies based on their particular size and migration patterns. With this important nuance now clearly established, the story shifts back toward the dramatic physical confrontation itself, examining exactly what happens to the orcas involved during these incredibly risky, dangerous hunting attempts, and exactly how much danger these skilled predators genuinely face throughout the entire process. Every successful blue whale hunt comes with genuine, serious risk for the orcas involved, not just the whale being targeted. Throughout the 20-minute attack sequence detailed earlier, hunting orcas repeatedly expose themselves to potentially deadly danger from the whale's powerful defensive tail strikes, accepting significant personal risk in exchange for an enormous potential food reward. Researchers documenting these confirmed attacks specifically noted the blue whale actively slapping and swiping its enormous tail throughout the entire duration of each hunt, using this powerful weapon as its primary and most effective form of active defense against the surrounding orcas. This wasn't a passive, helpless animal accepting its fate. It was an animal fighting desperately for survival, using everything available to it. As detailed in earlier chapters covering the physical mechanics behind these powerful tail strikes, a direct hit from a blue whale's fluke carries enough force to cause serious injury or even death to an orca unfortunate enough to get caught directly within striking range. This isn't a minor glancing risk easily dismissed. it represents a genuine, potentially fatal danger present throughout every single stage of the entire hunting process. Think about the sheer physical risk every individual orca accepts simply by participating in an attack like this. Positioning themselves close enough to grab onto fins, tails, or the whale's massive body requires accepting significant proximity to a weapon capable of seriously injuring or killing them with just one solid, well-placed strike landing at the wrong moment. This risk becomes particularly pronounced during the earlier stages of an attack, when the blue whale still possesses significant remaining strength and energy reserves. Early in the hunt, before extended exhaustion begins wearing down the whale's defensive capabilities, tail strikes likely carry their maximum possible force and remain most dangerous for any orca positioned too closely nearby. This explains part of the strategic reasoning behind why these hunts require such large numbers of coordinated participants in the first place, beyond simply overwhelming the whale's ability to defend multiple directions simultaneously. Spreading risk across a larger group of hunters means no single individual orca needs to accept disproportionate personal danger throughout the entire lengthy attack process. Despite this very real, ongoing risk, throughout every documented attack, researchers haven't specifically reported confirmed serious orca injuries or deaths occurring during any of the 3 documented hunting events analysed throughout their published research. This doesn't necessarily mean injuries never occur during these dangerous encounters. It may simply reflect the genuinely skilled, practiced nature of these specific hunting orcas, who've clearly developed effective techniques for minimising personal risk throughout the entire attack process. This apparent success rate reinforces an important point raised in earlier chapters regarding cultural learning and generational knowledge transfer within specialised orca hunting populations. Orcas that have spent years learning and practicing this specific dangerous hunting technique likely develop refined instincts regarding exactly how closely they can safely approach and precisely when the greatest danger from tail strikes genuinely exists throughout the extended hunting process. This combination of learned skill, careful timing, and strategic group coordination appears to significantly reduce, though certainly never completely eliminate, the genuine physical risk every individual orca accepts throughout each dangerous hunting attempt. Even skilled, experienced hunters continue operating within genuinely dangerous conditions throughout every single documented attack. Understanding this real, ongoing danger faced by the orcas themselves adds important balance and context to this entire predator-prey relationship. This isn't simply a story about an unstoppable predator effortlessly overwhelming a helpless, defenseless victim. It's a genuinely dangerous confrontation between 2 remarkably powerful animals, where even the eventual victor accepts real, significant risk throughout the entire violent process. With this important risk dynamic now clearly established from the orca's perspective, the story turns toward examining exactly how significant a single successful tail strike could theoretically become under the right specific circumstances. Somewhere within every documented blue whale hunt exists a single moment of maximum danger. One instant where a single, well-placed tail strike could theoretically end an orca's life almost immediately. Understanding exactly how much force this single blow could potentially generate reveals just how genuinely dangerous this entire hunting process actually remains for every participating predator. A blue whale's tail fluke, as discussed extensively earlier, represents an enormous muscular structure built specifically to move an incredibly massive body through dense ocean water. This same structure, when used defensively rather than for normal swimming, becomes capable of generating tremendous, potentially lethal force concentrated within a single sudden strike. Think about comparing this to something more familiar and easier to visualize. A solid hit from a professional boxer's punch can generate enough force to seriously injure or even kill an unprotected person under the wrong specific circumstances. Now imagine a strike coming from a structure many times larger and more powerful than any human limb, moving through water with the combined mass and strength generated by a 200-ton animal's absolute maximum defensive effort. This comparison, while imperfect given the completely different physical environments and species involved, helps illustrate the fundamental scale of danger present within a single, direct tail strike. An orca caught directly within the path of a full-force blow faces genuine risk of severe internal injury, broken bones, or other potentially fatal trauma resulting from just one single moment of bad positioning or unlucky timing. Beyond direct physical contact, the surrounding water itself becomes dangerous during a powerful tail strike. As mentioned earlier, discussing maternal defensive behaviour, the turbulence and pressure changes created by a forceful tail movement can affect nearby orcas even without direct contact occurring. An orca positioned just a few feet away risks being violently thrown off balance or seriously disoriented, potentially creating additional danger during an already chaotic, fast-moving attack sequence. This combined danger, direct impact alongside dangerous surrounding turbulence, helps explain why researchers specifically noted the whale's continuous tail, slapping and swiping behaviour throughout each entire documented attack. This wasn't simply random, panicked thrashing. It represented a genuinely effective defensive strategy, actively creating a dangerous zone surrounding the whale that every attacking orca needed to carefully navigate throughout the entire hunting process. Consider how this single potential danger shapes overall orca hunting strategy throughout an entire attack. Rather than approaching directly from behind, where tail strikes pose maximum danger, coordinated hunting groups likely prioritize careful positioning specifically designed to minimize direct exposure to this particular defensive weapon, while still maintaining enough proximity to execute the other coordinated tactics detailed earlier. This careful positioning requirement adds yet another layer of complexity to the already impressive coordination required for these attacks to succeed. Individual orcas must simultaneously track their own position relative to the dangerous tail, monitor the positions of other pod members working alongside them, and maintain enough overall pressure to prevent the whale from escaping or catching a full breath, all while avoiding a single potentially fatal mistake throughout the entire process. The genuine possibility of a single fatal blow adds important weight and context to everything discussed throughout this entire story. Every documented successful hunt represents a genuine gamble for every participating orca, one where skill, experience, and careful coordination significantly improve the overall odds of success, but never fully eliminate the fundamental danger inherent within challenging the single, largest, most powerful animal that has ever existed throughout the complete history of life on Earth. Understanding this genuine mutual danger present on both sides of this predatory relationship naturally raises an important question regarding exactly which specific survival strategy ultimately proves more valuable throughout an extended, dangerous confrontation like this: raw power and defensive capability, or patient, sustained effort over time. Throughout this entire story, one important pattern keeps appearing again and again. Raw individual power alone rarely determines the final outcome during these dangerous confrontations. Instead, sustained effort, careful patience, and long-term endurance consistently prove more valuable than short bursts of maximum individual strength or speed. Consider everything discussed earlier regarding the blue whale's impressive individual capabilities. Its powerful heart generates incredible speed and stamina. Its massive tail delivers potentially lethal defensive strikes. Its overall size alone provides substantial protection against nearly every other predator found throughout the entire ocean. Individually, each of these specific advantages represents genuine, significant power. However, as detailed extensively throughout this story, these individually impressive advantages ultimately prove insufficient when facing a coordinated, patient predator group willing to sustain pressure across an extended time frame. The whale's speed, while impressive, cannot be maintained indefinitely without eventually requiring rest. Its powerful tail strikes, while genuinely dangerous, can only threaten one specific direction at any given moment. This creates an important pattern worth examining closely. Orcas succeed specifically because they don't attempt to directly match or overpower the blue whale's individual strengths. Instead, they exploit the fundamental limitation present within any single burst of power or speed: the simple, unavoidable fact that no individual advantage can be sustained indefinitely without eventually requiring some form of rest or recovery. Think about comparing this dynamic to a long-distance running race rather than a short sprint. A runner capable of incredible short bursts of speed might easily win a 100-meter dash, but that same runner, if forced to maintain that identical pace across an entire marathon, would likely collapse from exhaustion long before ever reaching the finish line, while a patient, steady runner conserving energy throughout the entire race ultimately proves more successful across that same extended distance. This same fundamental principle applies directly throughout the entire predatory relationship discussed throughout this story. The blue whale possesses genuinely superior individual power and speed compared to any single orca. But orcas don't need to match that individual power directly. They simply need to sustain coordinated pressure long enough that the whale's individual advantages eventually become exhausted through extended continuous use. This explains precisely why the large group sizes detailed earlier prove so critically important throughout these successful hunts. A larger coordinated group allows continuous rotating pressure throughout an extended attack, ensuring the whale never receives genuine relief or recovery time, while individual orcas can rotate positions, allowing some members brief moments of rest, even during an active, ongoing attack sequence. This pattern extends beyond simply this specific predatory relationship into a broader principle worth considering throughout the natural world generally. Genuinely successful predators frequently succeed not through possessing superior individual raw power compared to their prey, but through superior strategy, patience, and sustained coordinated effort applied consistently over an extended period. Understanding this broader principle helps explain why orcas specifically, rather than any other individually powerful ocean predator, became the one species capable of successfully overcoming the blue whale's impressive individual defensive advantages. It wasn't about matching power with equal or greater power. It was about applying patient, sustained, coordinated pressure specifically designed to exploit the fundamental limitations present within any individual advantage, no matter how impressive that advantage initially appears. This important principle regarding endurance versus raw power adds valuable broader context to everything explored throughout this entire story. With this key insight now clearly established, the story moves toward its final, broader reflection regarding exactly what this entire predator-prey relationship reveals about genuine intelligence throughout the natural ocean world. Step back from every individual detail explored throughout this entire story, and a much larger, more significant picture begins emerging. This isn't simply an interesting account regarding one specific predator successfully hunting one specific type of prey. It represents a genuine window into exactly how sophisticated true intelligence throughout the natural ocean world actually becomes when tested against seemingly impossible odds. Consider everything required for orcas to successfully accomplish what no other ocean predator has ever managed throughout the entire recorded history of marine biology. Complex social learning passed carefully across multiple generations, sophisticated communication systems coordinating numerous individual hunters simultaneously across significant distances, advanced sensory capabilities through echolocation, providing detailed spatial awareness throughout chaotic, fast-moving conditions, patient, sustained strategic thinking specifically designed to exploit fundamental limitations present within an incredibly powerful opponent. This remarkable combination of abilities reveals something genuinely significant about orca intelligence specifically, extending well beyond simply representing an impressively capable ocean predator. It demonstrates genuine problem-solving capability applied toward one of the most physically challenging predatory problems found anywhere throughout the entire natural world, successfully overcoming an opponent possessing enormous individual advantages in size, strength, and raw physical power. Scientists studying orca behavior and intelligence increasingly recognize these animals as possessing cognitive capabilities rivaling and in certain specific ways potentially exceeding those found within many other highly intelligent species throughout the animal kingdom. The ability to develop, refine, and successfully pass down specialized cultural knowledge across multiple generations represents a particularly sophisticated cognitive achievement, one long considered largely unique to human societies specifically. This broader recognition regarding genuine orca intelligence carries important implications extending beyond simply understanding this one specific predatory relationship. It suggests the overall ocean environment likely contains significantly more sophisticated, complex behavioral patterns and relationships than previously understood, patterns that remained completely hidden from human observation simply due to the inherent challenges involved in studying animal behavior occurring across such vast, difficult-to-observe ocean territory. Think about how many other similarly sophisticated behavioral patterns might currently exist throughout various ocean regions worldwide. Patterns involving different species entirely that simply haven't yet been documented or fully understood by dedicated researchers. The blue whale hunting behavior detailed throughout this entire story remained completely undocumented for decades, despite clearly representing an established ongoing behavioral pattern, likely occurring for a considerable period beforehand. This raises an important, broader question worth genuinely considering. If something as dramatic and significant as successful blue whale predation remained hidden from scientific observation for so long, what other remarkable, sophisticated behaviors might currently exist throughout the world's oceans? Patterns involving intelligence, coordination, and strategic thinking we simply haven't yet had the opportunity to properly witness and document. This broader uncertainty regarding exactly how much remains genuinely unknown throughout ocean environments worldwide adds important humility to our overall scientific understanding regarding marine life generally. Despite significant advances throughout modern marine biology and ocean research, this story clearly demonstrates that even the largest, most dramatic behavioral patterns can remain completely hidden from scientific observation for a remarkably long period of time. This entire predator-prey relationship, when fully understood and appreciated, ultimately represents something far more significant than simply an impressive example of successful predation occurring at an enormous physical scale. It represents genuine proof regarding exactly how sophisticated, strategic, and remarkably intelligent behavior can develop throughout the natural world, even when facing what initially appears to represent a completely impossible physical challenge. With this broader reflection regarding genuine ocean intelligence now clearly established, the story arrives at its final, concluding chapter, examining exactly how this entire complex predator-prey relationship ultimately balances out, and what continues allowing the blue whale to persist as a remarkable, resilient species despite facing this uniquely sophisticated predatory threat. Despite everything detailed throughout this entire story regarding the genuine danger orcas represent toward blue whales, one important final truth remains absolutely clear. The blue whale continues surviving, continues recovering, and continues thriving as a species, despite facing one of the most sophisticated, coordinated predatory threats found anywhere throughout the natural ocean world. Remember the scarring evidence discussed earlier throughout this story, revealing that approximately 1 in every 4 blue whales studied within certain populations carries visible proof of surviving a serious predator encounter. This statistic ultimately reveals something remarkably positive and encouraging, rather than something purely alarming. The overwhelming majority of documented attacks throughout blue whale populations worldwide ultimately end in successful escape, rather than successful predation. This important balance reflects the genuine effectiveness of everything discussed earlier regarding the blue whale's impressive individual defensive capabilities, its incredible speed and remarkable endurance, its powerful, potentially lethal tail strikes, its overall enormous size, providing substantial protection against all but the most specifically specialized, coordinated predator groups. These defensive advantages, while ultimately insufficient against the most skilled, experienced orca hunting populations, remain genuinely effective throughout the vast majority of potential predatory encounters occurring throughout the world's oceans. Consider also everything discussed regarding exactly how geographically limited genuine blue whale predation risk truly remains throughout the entire species' overall range. As detailed earlier, only a small handful of highly specialized orca populations, concentrated within specific regions like Bremer Canyon, possess the accumulated cultural knowledge and refined hunting strategy necessary for successful predation. The vast majority of blue whales traveling throughout most of the world's oceans face minimal direct predatory risk from orcas throughout their entire lives. This creates a genuinely balanced, sustainable predator-prey relationship, rather than representing some kind of existential threat to toward overall blue whale population recovery. Nature frequently establishes exactly this type of balanced relationship between predator and prey species over extended evolutionary timeframes, one where genuine predation occurs regularly enough to represent an authentic ecological relationship without occurring frequently enough to seriously threaten overall population stability or long-term species survival. Blue whales continue demonstrating remarkable resilience, despite facing this sophisticated predatory challenge, alongside numerous other significant threats, including ship strikes, fishing net entanglement, and broader ocean environmental changes. Current population trends throughout most studied regions continue showing gradual, positive recovery, suggesting the species maintain sufficient overall resilience to continue thriving despite facing this specific predatory pressure, alongside everything else challenging their ongoing survival. This remarkable resilience ultimately reflects something genuinely inspiring about the blue whale as a species specifically. Despite representing the single largest animal to ever exist throughout the entire history of life on Earth, despite facing devastating historical population losses through commercial whaling, and despite facing this sophisticated, coordinated predatory threat detailed throughout this entire story, blue whales continue persisting, continue recovering, and continue maintaining their remarkable position as the ocean's most magnificent living giant. The relationship between blue whales and their orca predators ultimately represents something far more nuanced and genuinely fascinating than a simple, one-sided story regarding an unstoppable predator versus a helpless, defenseless victim. It represents two remarkably sophisticated, powerful species locked within a genuine, balanced natural relationship, one built on mutual danger, respect, and an ongoing evolutionary contest that likely continues shaping both species moving forward across future generations. This uneasy, complex balance between predator and prey ultimately reveals something profound regarding the true nature of survival throughout the natural world generally. Even the largest, most powerful animal that has ever existed throughout our planet's entire history still exists within a complex web of genuine danger and vulnerability. Yet through remarkable individual strength, impressive speed and endurance, and the simple, powerful advantage of scale itself, the blue whale continues enduring, continues thriving, and continues reminding us that even in an ocean containing genuinely sophisticated, intelligent predators, true survival ultimately comes down to remarkable resilience carried forward across countless previous generations.